So test tomorrow is on 7.4, 7.5, 8.2, and 8.3. So let's take a look at number 1 and 7.5. When we have a fraction is equal to a fraction, how would I solve here? Cross multiply, thank you. So we have 3 times x minus 2 is equal to 5 times x plus 2. What would I do next? Distribute. So 3x minus 6 is equal to 5x plus 10. Don't forget to distribute to the second number too. That was a common mistake that people made on the quiz. What do I do next? Combine like terms. So I'm going to move the x's to one side and move the constants to the other. So I subtracted 3x to move it to the right. So I'm going to move the 10 to the other side. So numbers with terms with an x go to one side, terms without an x go to the other. So I have negative 16 is equal to 2x. What would I do next? Divide by 2. So what does x equal? Negative 8. Awesome. All right, let's take a look at number 8. So when solving, when I have more than one fraction on a side, I have to find the least common denominator first. What would my least common denominator be here? X times x minus 6 for number 8. So once we figure out what our least common denominator is, we have to multiply that to everything. So everything gets multiplied times x and x minus 6 times x and x minus 6 times x and x minus 6. What would I do next? Cancel out. If it's already in the denominator, I don't have to multiply that term. So here, in my first spot, I'm just multiplying 5x. If it's already in the denominator, we don't have to multiply that one. So in the second fraction, I'm going to cancel out the x's. So next, I have 1 times x minus 6, which would just be x minus 6. And then in the third one, I'm going to cancel out the x minus 6. So here I'm multiplying x times x minus 1. Any questions on what I did here? What would I do next to solve? I can distribute the x. So anything that needs to be distributed, make sure you distribute it to simplify. So I have x squared minus x, and then what should I do? Combine like terms. So 6x minus 6 is equal to x squared minus x. Then what? If I have an x squared and an x, what am I going to have to do? Factor. So what does it have to be equal to if I'm going to factor? It's got to be equal to 0. So I have to move everything over to one side. So I'm going to keep that x squared where it's at and move everything to the right side. So I'm going to subtract 6x, combine that with the x. So I'm combining my like terms here too. And then I'm going to add 6. Be careful when moving things over to the other side. A lot of people, instead of adding 6, they did minus 6. So then their numbers were off on one side. So like here, they would have said plus 6. So just be careful with the signs. So this is 0 is equal to x squared. What is negative x minus 6x? Negative 7x plus 6. Now we can factor. Do I have two factors of 6 that add to negative 7? Negative 6 and negative 1. So x minus 6 times x minus 1 is equal to 0. What would I do next? Set them both equal to 0. So x minus 6 equals 0. X minus 1 is equal to 0. So what does x equal? 6 and 1. When I get two answers, what do I have to do? Check. What are we checking for? 0 in the denominator. We cannot have 0 in the denominator. Awesome. Let's start by plugging in 6. We only have to plug it into the x's in our denominator to see. So if I have 6 minus 6, what's that? 0. So does 6 work? No. Let's just check 1 just to be super sure that 1 works too. What's 1 minus 6? -5. So not 0, so it works. 1 in the denominator is just 1, so that works. And 1 minus 6 is -5, so not 0. So that 1 works. You cannot have 0 in the denominator. So if you end up with 2 answers, make sure you check. Okay, on the next page, let's start with 8.2. 8.2 is our arithmetic section. What does it mean to be arithmetic? Perfect. It has a pattern. We are adding or subtracting the same number, so a common difference. So our formula for arithmetic sequences it's a sub n is equal to a sub 1 plus n minus 1 times d, where a sub 1 is what? The first term. N is the number of terms. So it's how many terms we have. And then what's D? The common difference. So that's going to be the pattern, what we're adding or subtracting to get from one number to the next. So in the first section, we just have to tell if it's arithmetic, geometric, or neither. So let's see. Let's check arithmetic first. What am I adding or subtracting to get from 5 to 2? Subtracting 3. If I subtract 3, do I get -1? If I subtract 3, do I get -4? If I subtract 3, do I get -7? So is this arithmetic? Yes. Let's do number 2. What am I adding or subtracting to get from 9 to 7? Subtracting 2, so -2. What about from 7 to 4? Subtracting 3. If these two numbers are different, do I need to keep going? No. So is it arithmetic? No. We could check to see if it's geometric. Am I multiplying anything to get from 9 to 7? No. So it's not geometric, it's not arithmetic, so then what? Neither. Any questions here? Let's do number 3. What am I adding to get from 1 over 3 to 2 over 3? 1/3. Perfect. If I add 1/3, do I get 3 over 3? Yes. And so on and so forth. We add the same number each time. So is it arithmetic? Yes, because we're adding the same number. Let's take a look at 4. What am I adding to get from 1 to 3? I'm adding 2. What about from 3 to 9? Adding 6. So is it arithmetic? Nope. So let's check geometric. What am I multiplying to get from 1 to 3? 3. If I multiply 3, do I get 9? If I multiply 9 by 3, do I get 27? If I multiply 27 by 3, do I get 81? So is this arithmetic, geometric, or neither? Geometric. Okay, for the next part, we have to write a rule for the nth term of the sequence, then find a sub 20. So we need to use our formula to write the rule. A sub n is equal to a sub 1 plus n minus 1 times d. So a sub 1 is our first term. What is our first term for number 6? 15. So a sub 1 is 15. D is our common difference. What's our common difference? What am I adding to get from one number to the next? I'm adding 7. So 7 would be my common difference. So let's plug those in for our rule. A sub n is equal to 15 plus n minus 1 times 7. Now you can leave it like this, but if this question were multiple choice, it would be simplified. How would I simplify this? Distribute the 7. Awesome. So we have 15 plus 7n minus 7. Be careful. Don't forget to distribute it to both numbers on the inside of the parentheses. Then what would I do? Combine like terms. What's 15 minus 7? 8. So 7n plus 8 would be our rule. Yes. Next, this question asks us for a sub 20. So how would I find a sub 20? Plug in 20 into the n. So 7 times 20 plus 8. 7 times 20 would be 140 plus 8. So that would be 148. You get a calculator for tomorrow, so do not forget to bring your calculator. All right, let's take a look at number 9. Actually, we're going to do 8 and 9. So for number 8, I need to start with my first term. What's my first term? Negative 25. And then I need to know my common difference. What am I adding or subtracting to get from one number to the next? 15. If you don't see that right off the bat, remember to find the common difference. So to figure out what D is, you can always do the second term minus the first one. So when you get with negative numbers or fractions, it's a little bit harder to see. So to find your common difference, you could always just do the second term minus the first term. Also, if it's difficult to see what you're adding to go from negative 25 to negative 10, maybe look at the other numbers. Here it's a little bit easier to see. I'm adding 15 to go from 5 to 20. So because there's a common difference, it's going to be the same number here. So I'm adding 15. So our common difference is 15. So let's plug it in. I have a sub n is equal to what? Negative 25 plus n minus 1 times 15. Let's simplify this a little bit. How would I simplify? Jordan, how would I simplify? Distribute. So 15n minus 15. So negative 25 plus 15n minus 15. Distribute. And then what would I do next? Combine like terms. So 15n minus 40. So that is my rule, my simplified rule. Now how would I find a sub 20? Plug 20 into n. So 15 times 20 would be 300. 300 minus 40 is 260. So if you can't see like what you're adding to get from one number to the next, you could always do for like number 6, 22 minus 15, which would give you 7. That's your common difference.
But like, could you do that for 8?
Same thing with 8. You'd do negative 10 minus negative 25. This turns into a plus, so negative 10 plus 25 would be positive 15.
I thought it would be like negative 35.
Well, be careful because it's minus a negative, so it turns into a plus, so it's plus 25.
Okay.
All right, let's do number 9. Our favorite fractions. What's our first term? Negative 3. What's my common difference? 3 over 2. If you can't see that going from one term, from the first term to the second, maybe look at what you're adding to get from 0 to 3 over 2. It's a little bit easier to see here. If I add 3 over 2 to 0, I get 3 over 2. So then you could check the rest and see Am I adding 3 over 2? Yes. So our common difference is 3 over 2. So let's plug it into the formula. A sub n is equal to our first term plus n minus 1 times 3 over 2. What would I do next to simplify, Jordan? Distribute. We're going to distribute the 3 over 2. So negative 3 plus 3 over 2 times n minus 3 over 2. What would I do next? Combine like terms. So 3 over 2n. I'm going to add that on the side. So negative 3 minus 3 over 2. I'm combining my like terms over here. Just because it's fractions, I want to write it out. How do I add or subtract fractions together? What do I need? A common denominator. So I could make 3 over 1. And how do I get this to be a common denominator? Multiply the top and the bottom by 2. So I would make it negative 6 over 2. Negative 6 minus 3 is what? Negative 9. So that would be negative 9 over 2. So our rule is 3 over 2 times n minus 9 over 2. All right, we also have to find a sub 20. So how do I find my 20th term? Plug 20 into n. So 3 over 2 times 20 minus 9 over 2. So that would be 60 over 2 minus 9 over 2. And what's 60 minus 9?
51.
So 51 over 2. All right, let's move on to 8.3. So 8.3, we have geometric. So our geometric formula is a sub n is equal to a sub 1 times r to the power of n minus 1. What's our r? The common ratio. That is what we're multiplying to get from one term to the next. A sub 1 is the same thing. What's a sub 1? First term. And then n is the number of terms. So just be careful because you have a different formula for geometric. What does it mean to be geometric? Multiply a common difference to get from one number to the next. So let's look at number 1. What am I multiplying to get from 3 to 6? Multiplying 2. What about from 6 to 18? 6 to 18? You're multiplying 3. Do these have a common ratio? No. So is it geometric? No. Let's just double check to make sure it's not arithmetic. What am I adding to get from 3 to 6? Adding 3. If I add 3, do I get 18? No. So is this arithmetic, geometric, or neither? Neither. Before we get to number 3, just like how we had a kind of formula to find the common difference in 8.2, we have a little formula to find the common ratio. So to figure out what r is, you could always do the second term divided by the first term. So this is kind of like a shortcut way to find what your common ratio is. So sometimes, like in number 3, it's a little bit harder to see, Jordan. It's a little bit harder to see what you're multiplying to get from one number to the next because we have decimals. But you could always do 3.5 divided by 0.7. And what do we get? 5. So we're multiplying by 5 to get from one number to the next. If I multiply 3.5 times 5, do I get 17.5?
Yes.
Yes. Now this is easy to check because you guys have your calculator, so just plug it into your calculator, multiply times 5. Do I have a common ratio here?
Yes.
Yes. So is it arithmetic, geometric, or neither? geometric. Let's look at number 2. So let's check geometric first. Again, when you have really big numbers or when you have decimals, it might be hard to see what you're multiplying to get from one number to the next. So what you could do is take your second term divided by the first term and then simplify it. So this would be 1/3. So I'm multiplying by 1/3 to get from one number to the next. If I multiply 54 by 1/3, do I get 18? Yeah. If I multiply 18 by 1/3, do I get 6? If I multiply 6 by 1/3, do I get 2? Yes. So is this arithmetic, geometric, or neither? Geometric, because I'm multiplying. Remember, it's always multiplying, but sometimes you just are multiplying by a fraction. Always, always multiplying for geometric. All right, let's do 4. For 4, what am I multiplying to get from one term to the next? 2. Let's check. So I would multiply by 2/1. To multiply fractions, multiply the tops together, multiply the bottoms together. So that would give us 10/3. Perfect. So we're multiplying times 2. If I multiply 10/3 times 2, I get 20/3. If I multiply 20/3 times 2, I get 40/3. And lastly, I get 80/3. So is this arithmetic, geometric, or neither? Geometric. For number 5a, we're just plugging everything into our formula. So it gives us the first term. So this would be our a sub 1. And it says each term is 7 times the previous. So what's my common ratio? 7. So let's plug that in. A sub n is equal to -12 times 7 to the power of n minus 1. This would be our rule. All right, for 6 through 9, we have to write a rule for the nth term of the sequence, then find a sub 7. So let's look at number 7. What am I multiplying to get from 80 to 20? 1/4. Perfect. Again, I'm multiplying 1/4 to get from 20 to 5, and 1/4 to get from 5 to 5/4. So what's my first term here? 80 is my first term. What's my common ratio? That's 1/4. So let's plug it into our formula. A sub n is equal to what? 80 times 1/4 to the power of n/1. That is our rule. So it's asking us for the 7th term. So we have 80 times 1/4 to the power of 7 minus 1. So that's 80 times 1/4 to the power of 6. Be careful. You have to do the exponent before you multiply. It will give you a different answer if you multiply first. So you have to do the exponent. I'm going to do the exponent in 2 different steps. I'm going to distribute it to the top and the bottom. What's 1 to the 6th power? 1. And then let's see, 4 to the 6th power is 4,096. And then I multiply this times 80. So I get 80 over 4,096. I can simplify this fraction. I think 16 goes into both of them. So 256, 80 divided by 16 is 5. So we get 5 over 256. So we just simplified by dividing 16.
Where does 16 come from?
To simplify, that's what's in common on the top and the bottom. To simplify your fraction. So this would be our 7th term. Now, it would be okay to leave it as a decimal, but if this question was multiple choice, you would see it as a simplified fraction. So one way is you could just take all of your answer choices and divide them and see what decimal equals your decimal. So you could do it that way too. Let's do number 9. So we need to figure out what our first term is and our common ratio. So what's our first term? 1.2. Now for our common ratio, remember you could always do the second term divided by the first. So we could do negative 2.4 divided by 1.2. Just throw that in your calculator. What do you get for R? What do you get for R? Negative 2. So we're multiplying times negative 2 to get from one number to the next. So our common ratio is negative 2. So let's plug it in. A sub n is equal to what? 1.2. Awesome. 1.2 times negative 2 to the power of n minus 1. So this would be our rule. Now it's asking us for the 7th term. So how do I find A7? Plug in 7 into n. So 1.2 times negative 2 to the power of 7 minus 1. 1.2 times negative 2 to the power of 6. If you do negative 2 to the power of 6 in your calculator, make sure you put it in parentheses. You end up with positive 64. So 64 times 1.2, 76.8. All right, let's do number 8 too. Since it's fractions, we can practice. So if everything else is a fraction except the first one, you could just make it 3 over 1 if you wanted to see, maybe make it a little bit more clear. So remember with fractions, we multiply straight across. You multiply the top times the top and the bottom times the bottom. What would I need to multiply to get from 3 to 6? 2. What do I multiply to get from 1 to 5? 5. So notice how for the next one, if I multiply 2, I get 12. If I multiply by 5 on the bottom, I get 25. So what's my common ratio? 2/5, 2 over 5. What's my first term? 3. So let's plug everything in. A sub n is equal to 3 times 2/5 to the power of n minus 1. Next, we want to find our 7th term. So I'm going to plug in 7. 3 times 2/5 to the power of 7 minus 1. So 3 times 2/5 to the power of 6. I'm going to distribute the 6 to the top and the bottom just to keep it as a fraction. So 2 to the power of 6 would be 64. And 5 to the power of 6 is 15,625. And then we multiply it times 3. Would be 192 over 15,625. Again, if you put it all in your calculator at once and you got a decimal, you could always just check the answer choices. Turn your answer choices into decimals to see which decimal matches yours. For the last two, we have to find the sum. So we have our two summations here. These two are different. One of them is geometric and the other one is arithmetic. Just by looking at the equations, so the equation part here, which one do you think is arithmetic? The second one. Why?
I just know because geometric is still power.
Awesome. If you want to think about it that way, you can. Look at our geometric formulas. They have an exponent. So this one has an exponent. So if it has an exponent, it's going to be geometric. If you look at the second one, it's kind of in the same form as our rules from the first part, from the arithmetic section. So the second one is going to be arithmetic. But a great way to think about it is if it has an exponent, that means that it is going to be a geometric one. So our two formulas are different for each of them. So the sum of a geometric sequence is a sub 1 times 1 minus r to the power of n over 1 minus r. So again, another way you could think about it is the one with the exponent has an exponent in the formula. So let's plug in everything. Well, we got to find everything. We need to figure out what a sub 1 is, r, and n. How can I find my first term? Plug in the first number that it gives us for n, so I'm plugging in 1 into n. 2 to the power of 1 minus 1 would be 2 to the power of 0. And what's 2 to the power of 0? 1. Anything to the power of 0 is 1. So our first term is 1. How would I find my common ratio? The number that has the exponent. So the number in front of the exponent, 2, would be our common ratio.
And the last one, n.
And then what would our n be? The number on top, 5. So let's plug everything in. So the sum is equal to our first term, 1 times 1 minus r, which is 2, to the power of n. It's 5 over 1 minus 2. Make sure you follow your order of operations. What do I have to do first here? The exponent. 2 to the 5th power would be 32. So I have 1 minus 32 over 1 minus 2. What's 1 minus 32? Negative 31. And 1 minus 2? Negative 1. Negative 31 divided by 1? Divided by negative 1. It's just 31. And then times 1 would also just be 31. So the sum of our 5 numbers is 31. Right, so our next one is arithmetic. Our arithmetic, the sum of arithmetic formula is S sub n is equal to n times a sub 1. Okay, so I need to find my first term, my last term, and the number of terms. So how do I find the first term? Same way we did last time. We take the first number and plug it into n. So 2 times 1 minus 1. What's 2 minus 1? 1. A sub n is our last term. How do I find the last term?
What's the last term? 1.
How do I find it? What do I need to do to find it? So we take the number on top and plug it into n. So to find the last term, we take the number on top and plug it into n. So 2 times 5 minus 1 would be 10 minus 1, which is 9. And then what's my number of terms? 5, the number on top. So let's plug everything into our formula. So S sub n is equal to 5 times 1 plus 9 divided by 2. So we got 5 times, make sure you follow your order of operations. We got to do the top part first in our parentheses. So it'd be 10 divided by 2. 5 times 5 would be 25. Awesome. So the sum of our 5 terms is 25.